It's time for you to start running your statistical analyses on your survey data for our research project. This video lecture will teach you how to run frequency tabulations and means analysis using SPSS, the statistical package for the social sciences. There is the assumption that you have prior knowledge of setting up the SPSS file, as well as determining when to use which of the various types of statistical tests. Focusing today on just the statistical tests that you are likely to use for our class assignment. Understand that there are lots of tests that you can choose from to run your analyses. We're just going to focus on the basic ones for this class. Again, a lot of our examples are going to come from the beginning of the semester survey that you may have completed at the beginning of this class. Now let's focus on running some frequency tables. These are good for variables that are gathering nominal or categorical data. For example, if you have a dichotomous variable such as do you read, yes or no, or a rating scale of poor, fair, good, or excellent, yes, you can run a mean on this. We'll talk about that later. But you can also run frequencies. What percentage or number of people said poor? What percentage said fair? What percentage said good? And what percentage said excellent? And then in terms of employment status, full-time, part-time, not employed, all of those are nominal or categorical variables. This will identify the number and the percentage of respondents who gave a particular answer. Here's an example of a dichotomous variable. In this case, each of these have a yes, no, and you could then put a graph together that says the percentage of people who said yes. So you'll see 82% of people said that they have read or listened to an audiobook in the last 30 days. Another example, how often do you eat meals in the car? You can put together a pie chart, for example, that shows the frequencies of each of those answers. And then how would you compare yourself to the average person in the following areas? On driving, you could again put together a graph for that. Do you celebrate Christmas, Hanukkah, both, or neither? And you can just append the actual frequency data. Another benefit of running frequency tables is that you can identify any errors that you might have in the data file. Those errors could be due to keying. Somebody entered the data incorrectly. Sometimes you are off on a field. You might have put two answers in the same field, or you may have actually skipped a field. But another one is branching errors. An example of branching errors, let's look at Q1 at the top over here. So if you have read something in the last 30 days, we might want you to ask the next question of rating how good it was. But if you said no, you have not, you want to be able to skip that question. So let's say that you have 42 people, or in a 100 sample size, 42%, who said that they have read a book in the last 30 days. We would want them to answer question 2. So then 42 people, and only 42 people, should be answering question 2. You can run a frequency table to determine how many people actually answered question 2. And if 43 people answered question 2, you'll know that there's an error in the file, and you'll want to find that extra person who accidentally answered question 2. You may also determine from running the frequencies that there are some areas that you have to identify missing values. You'll find this a lot in a scale question. So let's say question 4 has to do with satisfaction, and you want to run a mean, but the mean should only range between 1 of not satisfied to 3 very satisfied. But you happen to have a 4th column for those people who said they don't use it. You would then want to declare the 4th category of don't use as a missing value. This is a very simple procedure as well. You'll do analyze, descriptive statistics, and frequencies. And again, you can stop the video for this. This is what the dialog boxes will look like. Before we actually do this, let's talk about where you can find the various SPSS functions. You can find the functions in the data set, which of course includes both the variable and the data views, as well as the output window. In the variable views, you'll see across the top, there's analyze, as well as the same place in the data view. And you'll notice that the functions are the same on both the variable view and the data view, which means it's easy for you to, no matter which window you're in, to be able to run the SPSS statistics that you may need. And then if you go to the output window, across the top, you'll also see analyze, as well as most of the same functions that you would see in both the variable and data view. So Let's do it. So here we are in our data file. You will choose Analyze, Descriptive Statistics, Frequencies. No reason to run a frequency on case, but we will do print books all the way down to, in this case, the last variable in the file is data collection method. Bring those over, click OK, and now we have some data. So we're going to scroll up to the top. You can see that you've got this one summarization here, which tells you how many people answered each question. And you'll notice that when we get to ebooks, only 48 people answered the question. One person, in this case, left it blank. That's why it's called missing. You'll see the same thing here and here. Now this other question here, this one says nobody answered the question and we had 49 missing, which makes sense because this is on what other platform do you read books or magazines or anything that's text oriented, and nobody had given another option other than the ebook reader, tablet, laptop, and phone. So this is a frequency table on the first question on whether people read print books. You'll see that of the 49 people, 28 of them said that they read print books in the last 30 days. That equates to 57% of the 49. So 21 people said no, they have not read a print book in the last 30 days, which equates to 42% of 49. And you'll see that there's a table for every question in the survey that follows the same format. Here is a question where you can see a system missing of 1. We have 10 people who said yes, which equates to 20.4% of the sample. 38 people who said no, they don't use an ebook reader to read a book. That equates to 77.6%. We had one person who did not respond to the question, and that equates to 2% of the entire study. So the 20.4, the 77.6, and the 2.0 equal the 100%. But what happens if we take these guys out of the mix? So now we want 10 divided by 48, and that's this column of numbers. We have 20.8% of the people who said yes and 79.2% who said no. So that adds to 100%. Another column you might want to look at is this cumulative percent. So let's go down to something like this question here, which is how often do you eat fast food in the car? And we have categories of never, seldom, occasionally, frequently. We did have an always category, but since nobody responded, it doesn't show up on this table. So we know we have 16% who say that they never eat fast food in the car, and that shows up here under valid percent. And then you also see that in the cumulative percent column. We had 30.6% who said that they seldom eat. Now this 16.3 and the 30.6 combined equal that 46.9. And you can continue this. Looking here, you have 16.3% plus 30.6 plus 38.8 equals 85.7. So in some cases, this might help you add your numbers together without having to pull out a calculator. Now remember I said that you can often find errors here. Here's an example. We asked, how many days in a week do you typically eat fast food? And most of these make sense. You have 6 people, or 12% of the sample, who said they don't eat fast food at all. 1, 2, 3, 4, 5 days a week. There's no 6 and no 7 days a week, but all of a sudden this 8 days a week shows up. Last time I counted, there were only 7 days in a week. So how might you be able to find this? Well, here's how you do it. This is on number of days eating fast food. First thing you do is you go to your file and find out number of days eating fast food is question 4. Go to data view. There's question 4. You highlight that row, and here's these binoculars, and you say, I want to know where the 8 is there. So we do find next, and there's the 8. So you could then adjust that now. You might have to check all the other data in the file. So now we're going to go Analyze, Descriptive Statistics, Frequencies, and we're going to look at just that one question, which was this question 4, number of days eating fast food. We'll run it, and now you'll see that it's all fixed. So now you may want to run some means or determine the arithmetic average. You would do this for variables that are gathering scale or interval level data. You could also potentially use it for variables gathering ordinal level data. You would calculate the measures of central tendency, means, and the standard deviation. This first question, question 4, the number of days in a week that you typically eat at least one fast food meal, would be gathering data that you would want to run a mean on. You also could run means on these scale ones. We asked people to rate things from much worse all the way to much better, so it's a 1 to 5 scale. We might want to have means on every one of them, and that way we could plot to determine which ones had the highest means. Potentially, I said it could be used for ordinal level data, such as how often do you eat meals in the car? That is ordinal level. And you could run a frequency analysis on that, just like we talked about earlier, but you could also run a mean on that. Remember that you may need to identify some missing values. For example, on a 1 to 4 scale of poor, fair, good, excellent, if you allow 5s to stay in that file and run those, you will overinflate or overestimate your mean. So you would want to create 5 as a missing value, therefore it's excluded from the calculations. Very simple procedure, just like frequencies, only now instead you choose descriptives instead of frequencies. Analyze, descriptive statistics, descriptives. You may want to determine the range, identifying the minimum and maximum, and you would do that under the Options tab. So here is what you would see in terms of a dialog box. Descriptive statistics, descriptives, and then what you would see in the Options tab if you wanted to identify minimum and maximum. So now let's go ahead and do it. Let's run some means. We are back in our data file, so we'll want to analyze, descriptive statistics, descriptives, and now the ones that make sense to run means on, let's do frequency of eating in the car, the number of days that you eat fast food, all the way through the agreement ones, down to study ethic. And then the last one I thought that would be interesting is concern with doing well in this class. So we will move that over here. We'll go to options and just check to see what is marked. Again, mean, standard deviation, you could add variance, range, standard error of the mean, minimum and maximum, lots of things that you can do. We're going to do continue and OK. All right, here are your descriptive statistics. Here you say number of days eating fast food. 48 people answered the questions. The lowest value was 0, no days a week. The highest was 7. And the mean then is 2.02. And you've got standard deviation over here on the side. Here are the agreements in terms of how they assess themselves with others in driving. As remember, 1 is much worse and 5 is much better. And you can see a 3.88. You'll also see down here that, for example, healthy eating, nobody gave the first response of much worse than average. So you can again look down here and determine all of those means. Processing time. Can you identify which variables in your research project make sense to analyze using frequencies and which make sense to use for means? What is the difference between the percent and the valid percent columns in a frequency table? And then finally, why might it be important to declare missing values for some analyses that you might be using for means? Now you should know more about how to print out an SPSS codebook and running frequencies and means analysis. Next step will be running bivariate analysis or cross tabulations and means comparisons.